Okay guys, let's go back with creating that wireless network. Looks like there was some problem with the video, the way we are actually recording it. So I apologize for that. So what we're talking about is there is a home or a big space where we have n number of computers or devices which are connected to a Wi-Fi router. This is the ISP gateway, and then it goes to the internet, right? So the idea is like this, that every device in the network will have some sort of Wi-Fi module, and this gateway will transmit the Wi-Fi signals to all of the area, so that all of this area is covered by the Wi-Fi signals, right? Depending on the type of router and the technology you are using. So for example, 802.11b or A or G or N or A, B, G, N. N is very prevalent these days. So look for N. It has a better range as well as the bandwidth. So as we go from top to the bottom, the technology becomes better. A/B/G/N means it is capable of supporting 802.11a networks, B networks, G networks, N networks. Not necessary. You can actually go with N, G and N or BGN. It depends on the type of router. You need not to get very focused on this piece, as long as it is something latest, right? So the idea is it actually covers the whole area with the wireless signals. Whatever the devices are in the network, they are receiving that Wi-Fi signal, and they'll start communicating back and forth on this wireless, what we call it a channel, basically, right? So we are still I'm sorry, we haven't gotten to the logical network yet. We'll talk a little bit about a high-rise building kind of a network connection as well. I will go over it real quick, where we were talking about the router with a Wi-Fi signal built in. And most of the times in these kind of implementation, we will use access points. Access points is nothing but it's a wireless Wi-Fi device transmitter only. It does not have a gateway built into it. So access point, basically what it does, it extend the signal in a particular area. So in this case, if this was a high-rise floor, on floor 1 we might have n number of access points on the ceiling, right? These access points are connected through a wired connection back into a switch, and these switches might be connected together, right? And they basically come into a basement, or there might be like some sort of telecom room per floor. It's called IDF units sometimes, or maybe after n number of floors there is one floor they are using as the MDF, main distribution frame, where all of these switch connectivities are coming in, and then from here it actually goes to the internet or the outside world. So the access points will be actually used here, not the gateways. Not the routers with the Wi-Fi connections. So we talked about the Ethernet wired connections as well as Wi-Fi connections. Let's go to the logical connectivity of the networks. And before we actually go there, I would like to actually talk about IP addressing. When we talk about the logical networks. Logical connectivity. We are done with the physical connectivity. Now we are talking about logical connectivity. Where we say the logical connectivity, in order for the connectivity to happen in every network, each of the individual items, including the gateways, the switches, sometimes access points, we are talking about all of the client machines, like for example laptop machines or the desktop machines. Every machine has to be identified uniquely. So in order to identify that machine uniquely, we will give them an IP address. This is a very, very common term we use. So in order to do the addressing, we use the IP address. So most of the time, I think some of you guys might have some experience in IP addressing, where normally you might have seen addresses like 192. Okay guys, so we are going to talk about the classes of IP addresses in this particular shot. So there are actually 5 total classes of IP addresses, but for the sake of this video, I don't want to make it over complicated. So we will only talk about the major classes, which is class A, B, and C classes of IP addresses. So classes of IP addresses, we will say class. There are class A addresses, class B addresses, there are class C addresses. Then there are class D and E addresses as well, which we are not going to actually talk about because it is not so much it's not so much related to what you guys will be actually seeing in the field every day. So we'll talk about class A addresses, class B addresses, and class C addresses. So out of the class, like just as a reminder, we talk about the IP addresses are actually in 4 octets, 1, 2, 3, and 4. And they have numbers ranging from 1 to 255. So 1 to 255 for octet A, 1 to 255 for octet B, C, and D as well. Not this A, B, C, D, but these are octet 1, 2, and 3, 4. So in class A, the class A address is what we call it. The IP address ranges, and I will just keep it very simple, okay? Instead of using like 1.0.0.0 till some number, I will just say 1.x.x.x till 126.x.x.x, so that you remember that these are the octets we are actually changing. And so in class A, it's 1.x.x.x to 126.x.x network. 127 is actually a reserved IP which you cannot use. It is reserved for loopback addresses. I'm sorry to say that you cannot use. You can use it, but it is used for a very specific purpose. Any address which starts with 127 is actually a loopback address. You need not to actually worry about this at this moment. So the next address range will be 128.x.x.x till 191.x.x.x network, then 192.x.x.x network till 223.x.x.x network. It's more complicated than that, but for the sake of this particular screen, we will pay attention to only these numbers and the ranges what we are actually talking about. So this is only important. So what I mean by that is, if you want to like over complicate it, you know, it will be little we have to actually talk about other octets, like from 1.0.0.0 till 126 of some numbers. I don't want to confuse you guys at this moment, but this is good enough. In the next short, we are actually going to talk about private and public addresses for the networks.
Go.
Okay guys, so let's talk about as you know, the classes of the IP addresses. Class A, Class B, Class C, Class D, and Class E addresses. These segments of IP addresses are now actually distributed into 2 different segments. These segments are called private class or private IP addresses, and public IP addresses. So out of all of the classes we actually learned, a set of those IP addresses has been allocated to the private address space, which means that you are free to actually choose those segments of IP addresses in order to allocate those IP addresses into your private network, into your home network, into your office network, as much as you can actually allocate these IP addresses to your enterprise networks as well. So why this was done? Actually, there is a specific cause for that. So when the IP addressing committee or society or association, whatever you want to call, they initially actually worked on the IP addressing segments and the architecture and the standards behind it. During the allocation itself, they realized that if we are allocating these IP address segments to the people that frequently, eventually they will run out of the IP address space in the world. So if you guys notice, I don't know, the people who have been longer in the industry would actually know that the Internet Consortium, the people who own the IP address segments or the blocks, they used to actually allocate routable IP addresses to the companies for their private IP addressing space as well. So what was happening is the companies were using these routable IP addresses inside their network, which was actually a misuse nowadays of IP addresses. So what they come up with is, they said, hey, you know what, you guys are going to use these 3 blocks of IP addresses for your private IP address space, and everything else besides this private IP address space became a public IP address space. So what are those IP address segments? So those addresses actually, they allocated in a class A segment, class B segment, as well as class D segment. So in a class A segment, they have allocated 10.x.x.x network. In a class B segment, the address actually starts from 172.16.x to 172.31.x.x, and in the class C, it is 192.168.x.x network. So that is the reason. And so what happens is, in a class A segment, if you go through the calculation, these are around 16 million addresses. This is around 1 point something million address, and this will actually give you 65,000 something addresses. So what it means by that, these numbers are actually important. So what happens is, if you want to design an enterprise network where you have around 15 to 16 million hosts in the network, you can actually pick up this segment and start designing your network without even calling anybody. You are free to use this space. At the same time, you need to be aware that anybody else is also free to use this addresses. So if there is a big enterprise which uses 10.x.x, there is a very good chance that some other enterprise who has a bigger network as yours, they will also be using 10.x.x network. So there will be a clash when you want to actually route your network into their network, right? Or their network want to connect, not route. If you want to connect your network address space to their network address space. So there is going to be a clash. People in the industry, they also already know that migration happens, or masking of IP address actually happens when this kind of scenario actually exists, when the companies merge together, bigger companies merge together. At the same time, class B address is actually starting from 172.16.x.x. So x.x means you are allowed to actually change these addresses, and these are host addresses or subnet addresses also. We are not going to cover that topic because in itself it becomes a very big video in order to cover that particular subnet masking of IP addresses, but we'll keep it simple. X means you can change the number. The other number you cannot change the numbers. So these actually provide you around million addresses. So which means that if your network is as big as that it will require 1 million plus minus hosts, you are supposed to actually use this address. Can you use 10 at this moment? At that moment, yes you can, but that will be a wastage of IP address segments within your class itself. But you are free to use that. In a class C segment, what we use is 192.168.x.x, and they provide around 65,000 hosts, which means that these network segments are allocated to SOHO or which is called SOHO, small office, home office networks, or home networks, or small office networks as well. 65,000 hosts is a big number. So most of the time what you will see is IP address actually floating in this segment range, 192.168. probably 1.x. So what happens is, if you freeze this number, the total number of hosts you are actually allowed is from 1 to 255, which is around 254 addresses you can use in a network. So if you have to design a network of your home where you foresee that there will be 254 number of computers or IP devices which will be connected in your network, all you need to do is pick up this network segment and start changing this number. So we are going to use this as an example in order to design small office network in this example in the next screenshot. So before we go there, so these are the private IP addresses class. Anything except this is actually a public IP address space, which means that you will see those IP addresses in the network, in somebody else, in the routable network. Most of the time it's actually internet. So it's very clear. If you will not see any address on the internet which starts with 10, which starts with 172.16, or which starts with 172.31. This from 16 to 31 is 16, 17, 18, 19, 20 to 31. You will not see anything this one. So the moment you see these classes, you should know that these are private IP address classes, and you are supposed to use that for your private use, which is the inside of the network use. I hope this is clear to you guys. We are not going to cover the public because anything except private is actually public. So let's start designing a small network and start allocating the IP address space. Assume that we have 5 computers, right? Which is a small home. In the previous example, we said you can install a switch, or you can go by a gateway or a router which has 5 ports, 1, 2, 3, 4, 5, and which has a WAN port as well, or the internet port, right? That is actually powered. Internet port or a WAN port. This is actually a LAN port. Be careful to plug your computers in the LAN port, not the WAN port. WAN port is for the internet. That's why they say it's an internet port. And I will tell you why this is actually used like this, right? In the WAN port, it will get connected to the patch cord to your ISP, router, or a cable modem, and then it goes and connects to the internet. So now the physical connectivity is done. Again, physical and logical. So the physical connectivity is done. You use Ethernet ports here, the female Ethernet ports. You use some patch cords in order to connect these to the female ports at the router. You use another patch cord in order to connect this gateway to this one. So there are approximately 5 patch cords you will need. And then this network is actually connected. Most of the time, the ISP, your cable service provider or internet service provider will actually will give you connection up till this point. You go buy this router from the shop, like a mega store, a store, or online as well. So now there is an allocation. So most of these actually routers, they come most of the time they actually come pre-configured, but you need to understand why that information is there, right? So when you plug this, they will tell you, hey, can you in the manuals, in the user manual, they will say HTTP :/192.168.1.1. Most of the time it is like this. So what they actually want you to do is log onto internet browser or Firefox or whatever you want to use, Safari, and log onto this will actually open the configuration of this particular router, right? So 192.168.1.1 means this is the address of the gateway, which means that this is the address of this particular router at the LAN side of it. So this router has 2 IP address segments because it is connecting 2 networks. Which 2 networks? This is actually one of the network from here, right? The other network is actually this network. So this whole network is actually allocated a space of 192.168.1.x, and this outside segment will be the IP address which will be assigned to you by your ISP. It could be, just for the sake of example, it could be 1.1.1.1, which is not the case, but we'll assume that is. So there are 2 network segments we are actually trying to use, 192.168.1.x. Now, by learning this, you should immediately understand that because the IP address starts from 192.168, this is a private IP address class, and you are supposed to use in your inside network. And anything except, you should not worry about it because this will be assigned by your ISP through a DHCP service. We will talk about later in the video. So here we are actually dealing with 2 different networks, 192.168 and anything which is other than that. This router device we are using, I think it should be clear by now. The router is actually a device which connects different networks together. So here there is a network 1 segment and there is a network 2 segment. So this router is actually used in order to connect or route between these 2 segments. Makes sense? So out of this IP address class, you are actually allowed to change this last octet from 1 to 255. Actually 254, but we'll say 255. So pick up this network segment, start assigning the address, statically assigning the address. We'll start talking about statically assigning the IP address, and then we'll say if there are too many computers in the network, we can use a DHCP service in order to actually allocate these IP addresses dynamically, right? So statically we will assign the IP addresses. For the Windows users, real quick, you will go into the control panel, you will go into your adapter setting. In the adapter setting, there is a TCP IP v4 setting where you will actually assign these IP addresses, and I will go through what is the assignment. The assignment looks like, what is the IP address? You will say 192.168.1. Start with 10. This will keep it simple. They will say, what is the subnet mask? You will say the subnet mask is 255.255.255.0 because you are just changing this last octet. They will say, what is the default gateway? You will say 192.168.1.1, and there is a reason why. 1.1 is actually the gateway address. .1 is always, most of the time, people say .1 is actually the gateway address. So in the previous example, if you really want, I actually showed it in the previous videos, but real quick, all of this network needs to go to a gateway in order to exit out of this, right? So that exit out device is actually .1. So all of these devices will actually point to a router. So this is a router address. Default gateway actually means the router address. Then they will ask you what is the DNS service address, server address, DNS2. So it is always primary and secondary DNS server addresses. Your ISP will allocate these IP addresses to you, and sometimes it's automatically assigned through the router itself. Just for the sake of example, let's say it's 4.2.2.2 and 4.2.2.3. So now the next one address is .11, the third one is .12, and this is .13. So all it changes is this number will change, remaining everything will actually remain the same. So what you are actually doing is you are creating a community. You started building the houses, and within the houses you are allocating the address to these houses. So house number 1 is address is .11, the address is .12, .13. So the question is, what will happen if this was also .11? right? So the moment your mail actually arrives here at the router, this router will get confused that should I deliver this mail to .11 in this one or .11 at this moment. So they have put some intelligence into the networks. You might see there is a IP address conflict message sometimes in the computers itself. Windows computers actually show you, hey, I see an IP address conflict. IP address conflict means somebody else is also using the same address you are. I wish my neighbor could also tell me that. So that was just a joke. So start assigning these IP addresses. The default gateway is like this. You will get an IP from your ISP, and you're pretty much now ready to basically connect it to the internet. So the very first test you will do is ping is the command. This is actually an ICMP protocol which is simplified into ping, packet internet gopher, that's what it's called. So the syntax is something like that, C:, you will say ping, then a space, then you'll say 4.2.2.2. You can actually ping this address because it's a Google DNS server address. So what it means is, from your computer, are you able to reach the Google DNS server, right? So it will actually send you a reply to say reply received from this particular address. There will be some other additional numbers, don't get confused with it for now. It means you have a reachability. Once you have a reachability, there is a very good chance that you will be able to go to the internet browser and you will be able to actually browse the internet. So what's actually happening in the back end? I think you guys need to understand that, right? So let me explain it to you. So this is your machine, this is the gateway or the router, and this is the internet, right? So you assigned an IP address of 192.168.1.10. The subnet mask was 255.255.255.0, means you are going to change this number. The default gateway was 192.168.1.1. IP, subnet mask, and gateway address or default gateway address, right? So this was the assignment to your PC. This particular address is .1. This particular address is .10, right? And this one is the segment, the network segment. And this one is the whole network on this side. This whole network is actually assigned with 192.168.1.x/24. /24 means 888. 8 3s are 24. 888, 8 2s are 16, 8 3s are 24. So we are freezing these three octets between this IP address segment. That's why we are using it /24, but it means the same. It actually means 255.255.255.0. So now, and this network from here onwards, it will be a different network. I don't know what that network is because that network IP address segment is actually allocated by your ISP. So what actually happens in the router? In the router, we little bit touched in the previous screens that the router actually either does a NAT or either does a PAT. So what is NAT and a PAT? NAT is actually called a network address translation. Network address translation. PAT stands for port address translation. For the sake of this learning, we are not going to touch a lot about it, but let me give you what is the difference between this is. So every machine which is inside your network needs to go out, right? So there are two configurations. Either every machine picks its own IP address on the outside side and then go outside, or all the machines in the inside network only pick one IP address and go outside. So from here onwards, in order to go outside, you need to be dressed for the internet. That's the easiest way of understanding it. So imagine that you are actually wearing, you are in your home, you are in your relaxed pajamas, and now all of a sudden you want to go out to do something in the market, right? Or you want to go to the mall or something. So in order to exit your gateway, in order to exit your home, you need to be dressed differently, right? So what this dressing is, you need to actually shell out your pajamas and you need to get into a pretty dress which is actually ready for the mall. So what happens is you will shell out the private address space here and you will pick up a public IP address space and then actually go to the mall or go to the internet. So what means is, and this translation or this dress changing happens at the network address using network address translation or port address translation. So let's see what happens. Imagine that you have five computers here in the inside network, and you have five IP addresses being allocated to you from the ISP. It doesn't make sense because you're not saving anything. Most of the time it will be only one IP address. But in order to understand the network address translation, we need to go 5:5 example, which is 1:1 mapping. Network address translation is 1:1 mapping. This is many:1 mapping, right? So we have 5 IP addresses inside and we have 5 IP addresses outside. So say 192.168.1.10.11.12.13 and so on and so forth will get converted into an IP address. I'm just giving an example, right? 8.8.8.1 or 8.10, 8.8.8.11, 8.8.8.12, 8.8.8.13 and so on and so forth. So each IP address in the inside network is actually assigned an outside IP address, so which is network address translation. And these configurations are actually done in the gateways. These gateways are capable. The SOHO gateways are capable where you can actually do the network mapping. Most of the time, it's actually port address translation, which is many-to-the-one mapping. Means 5 addresses will only be allocated to one IP address outside, which is 192.168.1.10. To all of those addresses will only be given the same IP address, which is .10. Now you will be surprised why one can actually do all of this magic. So it is called port address translation.